Hello, my name is Jordan Wasson, and I am attending the Network Systems class for the spring of 2023. Today we're going to be discussing Transmission Control Protocol, or specifically known better as TCP. Let's start off by discussing what networking protocols are. These are essentially a set of rules that define how connected devices can communicate across the network. I think of these similar to highway laws or traffic laws. Essentially, what they are set to do is to ensure that data gets from point A to point B in a safe, encrypted manner. Very similar to how highway laws allow us to drive from point A to point B in a safe manner. So, what is TCP? Although I really have a definition of TCP that I could define for you right now, I found a better definition written by Kinsey Yassar and Ben Lutkovich. They state the following. One of the main communications protocols of the IPC suite, TCP, resides at the transport layer of the Open Systems Interconnection Model, or the OSI. It works with the IP, which defines how computers send packets of data to each other. Together, TCP and IP are the basic rules that define the internet and ensure successful delivery of messages over networks. Lutkovich and Yassar. Well, that's really a lot of words. What does that actually mean? It means that TCP works with Internet Protocol, or IP, to ensure that packets of data or messages are delivered to their correct location across the network. What essentially that means is that when I complete a command on my PC, TCP will make sure with the IP or the Internet Protocol that the command that I complete sends the encrypted packet of data from point A to point B without being broken into. When working together, these two protocols work as a GPS for data. The IP is the address, and the TPC is what completes the verification that it is on the correct path. Going back to that highway analogy, you can think of the TCP as kind of the brains behind the network, making sure that the address that you are putting into the GPS is correct and it is valid. Let's dive a little bit deeper into TCP. It lies within the transport layer of the OSI model. This kind of is an obvious thing to understand because TPC is about transporting data, but it's good to understand that on the different layers of the OSI model, it falls in layer 4, or the transport layer. It completes a three-way verification. Some people would call it three-way handshake, whatever terminology you prefer is fine. But it completes a three-way verification using checksums, sequencing, and flow control to verify the packets of data and where they need to go. It uses these three methods to make sure that what I'm sending is what I'm meant to be sending, and what that data that I'm sending goes from point A to point B in a very safe, encrypted manner. This verification ensures that there is no miscommunication. On top of making sure that this data gets from point A to point B and encrypted, it also makes sure that there is no cross-firing between data and causing something that my PC sent to another location to the wrong location. TCP only works through a direct connection. What that means is it has to be hooked up on a network for TCP to work properly. There are other methods, one specifically called UDP, that works through a wireless method, but at this time TCP only works through a direct connection. I hope that leaving here and after watching this video, you have a better understanding of what TCP is and how it works. The OSI model is vast and wide and has a a lot of information and a lot of steps and protocols within each. But TCP is one of the very first protocols that you're faced with, and I hope that um, you get a better understanding after watching this video. Thanks again. My name is Jordan Wasson. Have a good day.